there is the design margin built in. Of course, we have our standards that we have to go meet. However, what happens is stuff comes in heavier. I mentioned blast loads where how we handle load cases coming from the vehicle needs to be tight, but also the vehicle is continuing to design. And it's hard to anticipate their changes. So it poses challenges. We're working through them, like I said, on a daily basis in terms of back to our brute force integration, where we're making sure we're dealing with items real time, and we're just getting it done. Part of the structure, remember, the mobile launcher was originally intended for Constellation, a much smaller rocket. So design margins weren't necessarily put in for an SLS vehicle. So like I said, we did a project which made the flame hole larger for the larger vehicle, and we did structural modifications to accommodate the vehicle. But again, that was back in 2013 to 2015, we did that structural mod. 2 years later, the vehicle has also gotten smarter, and in some cases, we have to adjust to loads and what have you that come from them. Not that they've had a lot of significant changes, but again, any change that comes late is a problem when you're this far into the construction project. From dealing with a large construction project like we're dealing with, designers need to always keep in mind that you're dealing with construction. You're not dealing with, let's say, flight, down to the flight hardware level tolerances. And what I mean by that is you don't want to be expressing tolerances down to the 1/10 of an inch or 100th of an inch when you're dealing with guys that are used to constructing steel at the inch level tolerances. So you want to always be conscious of making sure your tolerancing and those types of things are relevant to the situation, because it can cause a lot of problems, and it really drives cost to deal with that. And other areas similar to that would be making sure you do not specify, say, materials, and in our case, cable that was only available from a single vendor, which again drives long lead times, cost, and so you want to always be conscious of those types of things, particularly on a construction project. For my success, we have developed a very close-knit team that is on site at the project site. That's very important from a dealing with problems real time, and the ability to adjust. And again, that has been probably one of the bigger keys to our success. I would say also developing close relationships with your contract managers, and making sure you have a very open discussions and relationship to be able to clearly talk through problems and make sure no one's holding anything back. And I think we have developed that with our contractor. And then I would say for me personally, it's been having a management team that is I'm very able to work closely with. Again, they sit right out with me in the field, and we are able to have, again, open discussion. We deal with challenges daily, and I think the ability to trust them, and which means I can delegate to them without reservation, is very important. The mobile launcher, again, a couple interesting facts. Let's see, there's 662 steps to go from the ground to the top, and that puts you about 400 feet off the ground when you're at the top of the mobile launcher. The base of the mobile launcher, which is many of the rooms that house a lot of the ground support equipment, is about over 20,000 square feet of area. So you could probably put, roughly 10 three-bedroom houses in there in terms of area. Let's see, we will weigh, when we're done, just the mobile launcher, about 10.5 million pounds. And ultimately, when we roll out to the pad with the vehicle unfueled, it'll be over 21 million pounds. I love working for NASA because as a child, basically, 4, 5, 6 years old, I did watch the moon landings, and it fascinated me from that point on. and knowing that NASA was the entity behind that, just to have the opportunity to then become part of the next great leap, which is going to Mars, just is fantastic. And you know, the people I work with are great people. Everybody's, you know, rowing in the same direction, trying to get us off the ground and on our way to Mars. So it's just a fantastic opportunity. Well, what I would tell, so to tell grade school kids up through high school, as far as STEM, is continue to work your engineering, your math, and you know, if you have an interest in the space business, don't think you've missed the boat with the current projects that are going on, because we're building a 30-year program, and you're going to inherit this if you come to work for NASA, and you're going to have to pick up where we leave off and carry us forward, because the people currently working it probably will not be working it by the time we actually land on Mars, and you need to be ready to take us forward. To be ready to inherit this this very large set of projects, you know, you got to study your math, your engineering, you got to do well in school. Ultimately, you got to take that onto your college years. What I would say too is any chance you get to tinker at home, take stuff apart, put stuff together, you'll be amazed at how something maybe you took apart as a teenager can translate to an idea that maybe gets you out of a bind when you're working at, you know, the level that we're working at today. So I would say take every opportunity to learn about mechanisms, parts, electricity, anything you can, because it ultimately will boil down to something, hopefully a simple fix that maybe, again, you did as a child.